Welcome back, smart mathematicians. We're going to do our question 1.3. The roots of an equation are x is equal to negative n plus or minus the square root of n squared minus 4mp, all divided by 2m, where m, n, and p are the positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Prove that x is a non-real number. Right, what information do we have here? If you check, right, m, n, and p form a geometric sequence, but from this equation here, we have this. What we call this? This is the discriminant, okay? So the discriminant here is equal to n squared minus 4mp. Right, and then if x is a non-real number, it means this discriminant should be negative. So the discriminant should be negative. And then when I'm saying negative, it means less than 0. Okay, if the discriminant, this expression underneath the root sign, is negative, then this whole thing here is non-real, because you cannot have a square root of a negative number. So we have to prove that. The discriminant is negative. Okay? Right. And then we're given the second set of data, which says that m, n, and p they form a geometric sequence in that order. So meaning that t2 divided by t1 is equal to t3 divided by t2. Okay? Right. Now, it means our t2 is n. So n over m is equal to p over n. Then we can cross multiply here, n times n, and then m times p. Okay, right, so it means n squared is equal to mp. N squared is equal to mp. But what did you say? We said the discriminant is what? This discriminant is n squared minus 4mp. So where there's mp, we can put n squared. Where there's n squared, we can put mp. So now we can say our discriminant here, therefore the discriminant is equal to n squared minus 4n squared. You see that? I've replaced mp with n squared here. Or where there's n squared, we can put mp. Where there's n squared here, we can put mp. Or discriminant is equal to mp minus 4mp. Right, and then we can simplify these two is it equations? Yes, there's an equal sign. So the equations. So discriminant is equal to, what is n squared? This is negative 3n squared. Okay, negative 3n squared there. And then or here is equal to, again, negative 3mp. Right. Now, n is a positive real number, so it means n squared here is going to be positive, but positive times negative, because it's going to be negative 3 times a positive number here, because this will give us a positive number. So negative 3 times a positive number will give us a negative number. This shows us that the discriminant here, is less than 0. We come this side again, m and p. We're told that they are positive real numbers. Okay, so it means positive times the negative here also will give us what? Will give us or show us that the discriminant is what? Is less than 0. So now, since the discriminant is less than 0, then we can say that therefore x is a non-real number. Okay, you just prove that x is a non-real number. So when x is non-real, or the roots are non-real, the discriminant is less than 0. You know that from the nature of roots, okay? That's what we're supposed to do there. Okay, we're going to meet when we're doing our question 2.